Hi, I'm Chris, and in this calculus video we're going to take a look at something called implicit differentiation. So implicit differentiation is going to be what we use when we have an equation like what we see here, where we have y equals 3x squared, and then if we notice we have another y term on the other side. So we have y terms on both sides, and a lot of times when we see something like that, it's kind of intimidating because we're used to seeing y equals and then we only have x's on the right. And when that's the case, we're going to use the rules we've already learned, like power rule, product rule, quotient rule, or chain rule. In this case, however, we're going to take a look at how we would take the derivative of something like this. So, the derivative of y we express as dy dx. And that's going to be equal to 3x squared gets derived by using power rule, and we do 2 times 3, which is 6, and we reduce 1 from the exponent, so we get 6x there. But now we have a y squared, and we're going to treat this similarly to how we used chain rule in the previous section, which means we're going to multiply our exponent times our coefficient, giving us a 2y to the first, but then we have to multiply that times the derivative of y, times dy dx. Now if we wanted to get dy dx by itself, here we could bring these two terms to the same side, which means that you would have dy dx minus 2y dy dx equal to 6x. And then we could factor out a dy dx, which is the derivative we're trying to find. So when we factor that out, we get 1, didn't mean to put the equals there. We get 1 minus 2y equals 6x. And when we isolate dy dx, we divide both sides by 1 minus 2y, and what we're left with is 6x over 1 minus 2y as the derivative of this original expression. So for implicit differentiation, just remember 2 important things in order to come up with your final derivative. The first, use chain rule. So when we have y squared, to get to 2y times dy dx, that's just an application of chain rule, which we've already seen. And then the second important thing to keep in mind is this next step: bring every term that has a dy dx in it, bring all of those terms to the same side. That will allow you to factor out the dy dx to find your final expression. For more practice, please visit our website at sandersandtestprep.com, and you can also watch more of our calculus-related videos at STP TV. Thanks for watching.